So good afternoon. So today's topic is about sampling and quantization. So when we are doing a sampling, we know that we'll be converting the analog signal into a digital signal. So the number of bits will be required to store the image or to be the n cross k. So the more the values of n, m, and g, the better approximations of a continuous images over on it. So we'll have a storage and processing requirements will be increased as well over there. Okay. So when we are saying about so what are all the effects when we are seeing up here? So actually, this is the effects of reducing spatial resolution. So when we are having a 1024, you can see the images, how brightness and intensity is what we have over on it. So when we have reduced this pixels, not 124 into 512 and 256, 128, 64, and 32. So this is the way to reduce the spatial resolution. So there is 1024 8-bit image has been subsampled into 32 cross 32 pixels. Okay. So the number of allowable gray levels when you are seeing up over here, it is shown about 256 into 56. So you can see the number of pixels how it has been broken down, and it has been shown with the row and column duplication through 256 into 128 and 164 and 32. So they have resampled into 2024. Similarly, this also one more example for reducing the gray levels. That is, we'll be reducing from 452 into 128 into 32 overall. Okay. The next thing we have to see about and zooming and shrinkage. That's zooming, which explains the increasing the resolution size of an image. So we know that we'll be using the options of a zoom, right? So this we can able to increase the size of an image. Similarly, shrinkage will be decreasing the resolution of an image. So that's what I have shown in the figures over. Okay. This is the concept of zooming and shrinkage. So whereas in the case of an zooming, we'll have a pixel replications and bilinear interpolation. So in the case of an pixel replication, so we'll have an interpolated pixel in the enlarged image, which is set to the gray level of its nearest pixel in the original image. Whereas in the case of an bilinear interpolation, we'll have an interpolated pixel in the enlarged image, which is set to the average 4 nearest pixels in the original image overall. So for zooming example, so I have shown over here with the top row, which has been images given in terms of 128, 64, and 32. So which has been zoomed to 1022. That is, we'll be using of an nearest gray level interpolation. But in the case of an bottom row, the same sequence which I have shown, but we have used the bilinear interpolation. There is a difference between the gray level and the bilinear interpolation. Whereas in the case of an shrinkage, there is by an integer number by directing some of the rows and columns of the image, and by a non-integer factor, it can be done as the inverse of zooming. So when you are showing about the relationship between pixels, we are having the terms neighbors, adjacency, path, connectivity, region, boundary, and distance. So the basic relationship between pixels, there is a pixel P at coordinates which has 4 horizontal and vertical neighbors. So we'll have a 4 neighbors, x plus 1 comma y, x minus 1 comma y, x comma y plus 10, and x comma y minus 1. Whereas in the case of diagonal neighbors of P, so we'll have x plus 10 and y plus 10, x minus 10 and y minus 10. So already x minus 10, y plus 10, and x plus 10 and y minus 10. So 8-point neighbors will it has to be multiplied with the 4 neighbors with the and the diagonal neighbors. So when you are defining adjacency, if they are neighbors and the gray levels are similar. Okay. So we set of gray levels, and similarly the gray level means that the gray levels of both pixels belong to the set P. For example, binary image will have the image to be 1, and the gray level image will have from 32 to 62. So we'll have a 2 types of adjacency, 4 adjacency and 8 adjacency. So this 2 pixels P and Q with the values from B and 4 are adjacent. If Q is in a neighbor, it is N4. And similarly, 8-point adjacency, you have the 8 adjacent value, if Q is in N8 of P. So in the case of 4-point adjacency, we'll have a broken path, and 8-point adjacency, we'll have a multiple path over on it. So whereas in the case of an M adjacency, 2 pixels P and Q with the values from P and M are adjacent. If Q is in N neighbor 4 or the diagonal, and the intersection has no pixels with the values in Q. Whereas in the case of a region, the R is to be the subset of pixels in an image. R is called a region if every pixel in R is compared to any other pixel in R. So boundary of a region will be from set of pixels in the region that have 1 or more neighbors that are not in R. So distance measures in the sense, so we'll have a pixel P and Q, and Z with the coordinates with X, Y, X, T, and V and W respectively. Where D is the distance functions with F என்ன பண்றோம் அப்படின்னா, if it is greater than or equal to 0 or equivalent to the value, if it is less than that value, and we'll have a circle equation with x minus of x whole square plus y minus of t whole square to the root of square root. For the distance, we'll have the there is x minus x plus y minus t for 4-point distance. So for 8 points, maximum value of the t. So in the case of the distance measure, this is nothing but the length of the shortest path between the two pixels. Whereas D4 and D8, that is the distance between Q and Q, which are independent of the pixels along the path. At DM அப்படிங்கிறது பார்த்தோம் அப்படின்னா, it depends on the value of the pixels between Q and Q. So the next thing we have to say about a linear and non-linear operation. So H is an operator, it whose inputs and outputs are images. So other H is linear. If for any two images F and G and any two scalar A and B. So next thing we have to see about an digital image processing. So in the case of a digital image processing, we have a image segmentation and thresholding. So thresholding again it is usually the first step in any segmentation approach. So segmentation part thresholding again is the first thing. So thresholding mathematically represent பண்ணலாம் அப்படின்னா, we have to pick some value. So we have a threshold value. So if the image f of x comma y is greater than t, we have to set the value to be 1. If it is less than or equal to t, the value should be equal to 0. Okay. So this is the imaging, that is the original image A, Q, K, J, 10. So that is the threshold image and so we have to playing robot, which means we should interpret the task in its hand order. So in the case of that, but we have to be very careful. அதாவது இப்போ என்னன்னு கேட்டோம் அப்படின்னா, threshold level கம்மி பண்ண என்ன ஆகும்னா, we could not able to find out the images. நம்ம அந்த பார்த்தோம் இல்லையா, அது எதுவுமே வராது. அதே மாதிரி ஜாஸ்தி ஆனாலும் what will happen அப்படின்னா, we'll get a blurred image. So we should be very careful in choosing the threshold level. Next, basic global thresholding. This அது வந்து பார்த்தோம் அப்படின்னா, it will be based on the histogram of an image. Or it will partition the image histogram using a single global threshold. The success of this technique on the it strongly depends on how well the histogram can be partitioned. Next, what is the algorithm which is behind over on it? So we'll have some steps just being followed over on it. So first, we have to select an initial estimate T. Select அதுக்கப்புறம் என்ன பண்ணணும்னா, we have to segment the image. So T என்ன பண்ணணும்னா, we have to produce into two groups of pixels, G1 and G2. So அந்த G1 அப்படிங்கிறது பார்த்தோம் அப்படின்னா, consisting of pixels with gray levels greater than T. அதே மாதிரி G2 பார்த்தோம் அப்படின்னா, consisting of pixels with gray levels less than or equal as. ஓகேவா? So இதோட average gray levels எடுத்து in G1 which will give to microven and G2 to give the microven. So first என்ன பண்ணணும், initial estimate capital T எடுத்துக்கணும். We have to segment the image into two groups of pixels, G1 and G2. Next, fourth step, we have to find the new threshold value. And the new threshold value is micro 1 and micro 2 divided by 2. So this step has to be repeated until the difference in T. T infinity also. So this algorithm works out when the histogram is suitable over on it. Okay. So the next thing, basic adaptive thresholding. So in the case of basic adaptive thresholding, so far we have seen about the normal thresholding over. Okay. So this basic adaptive thresholding that we can see in the next.